Imagine a sky that suddenly refuses to remain familiar. The stars above no longer feel like distant decorations but like engines of cosmic violence, and somewhere in that vast theater a massive star reaches the end of its life. If Earth were pulled into the vicinity of a supernova explosion, the event would not be a simple flash of light but a sequence of escalating catastrophes. A supernova is the death cry of a star many times larger than our Sun, releasing in seconds more energy than our Sun will emit over its entire lifetime. For a planet like ours to be drawn close to such an event would mean encountering forces so extreme that ordinary language struggles to describe them. The first sign would not be the explosion itself but the gravitational drama leading up to it. Massive stars that go supernova often reside in unstable systems, and if Earth somehow wandered into that region, our planet would feel the tug of a collapsing stellar core. Gravity would stretch and strain everything. Tides far stronger than any ocean wave would ripple through Earth's crust. Continents might fracture, oceans would surge unpredictably, and the very shape of the planet could distort under the influence of nearby stellar mass. Before the explosion even began, Earth's environment would already be in turmoil. When the star finally detonated, the initial burst of radiation would travel outward at the speed of light. Within moments, an intense wave of gamma rays and X-rays would sweep across space. These forms of radiation carry immense energy capable of stripping away atmospheres and disrupting molecular bonds. Earth's protective ozone layer would vanish almost instantly, leaving the surface exposed to relentless cosmic radiation. The sky would blaze brighter than 1,000 suns, yet the brilliance would carry lethal consequences rather than warmth. As the radiation storm washed over Earth, electronics and communication systems would fail. Satellites would be fried by the sudden surge of charged particles. Power grids would collapse under electromagnetic shock. The ionosphere would become chaotic, scattering radio signals and creating a glowing, unstable aurora across the entire sky. For a brief, surreal period, the night side of Earth might glow with eerie colors as charged particles interacted with the upper atmosphere. Yet beneath that beauty, the planet would be entering a phase of irreversible damage. The heat from a nearby supernova would not behave like sunlight. Instead a gentle warming, it would arrive as an overwhelming blast of energy. Oceans would begin to evaporate at the surface. Water vapor would thicken the atmosphere, trapping even more heat and accelerating the planet's transformation into a furnace. Forests would ignite spontaneously. Cities would crumble as materials expanded and cracked under sudden thermal stress. Even deep underground, the rising temperature would begin to alter rock structures and destabilize tectonic plates. The shock wave itself would arrive later, traveling slower than light but carrying enormous momentum. This expanding shell of stellar debris moves at thousands of kilometers per second. When it struck Earth, it would compress the atmosphere violently, creating winds far beyond anything ever experienced. Mountains could erode within hours. Dust and debris would fill the air, blocking what little stable light remained. The impact of that shock wave would likely strip away large portions of Earth's atmosphere, sending gases spiraling into space and leaving the planet exposed and airless. Without a stable atmosphere, the temperature on Earth would swing wildly. One side of the planet might be scorched by residual radiation while the other plunged into freezing darkness. The oceans, already evaporating, would continue to dissipate into space. Life as we know it relies on delicate balances of pressure, temperature, and chemistry, all of which would be shattered. Even extremophile organisms that thrive in harsh environments would struggle to survive such relentless bombardment of radiation and heat. The surface of Earth would become a landscape of molten rock and fractured terrain. Lava flows might spread as the crust weakened under thermal stress. The magnetic field, already strained by intense radiation and particle streams, could collapse or fluctuate unpredictably. Without a strong magnetic shield, charged particles would penetrate deeper into the planet's surface, further destabilizing any remaining ecosystems. The once blue planet would begin to resemble a barren, glowing ember drifting through space. Interestingly, while the near side of Earth would suffer immediate devastation, the far side might experience delayed destruction. The planet's rotation would expose all regions to the supernova's effects over time. No corner would remain untouched. Even if some pockets of life initially survived underground or beneath oceans, the long-term environmental collapse would eventually reach them. The chain reaction of atmospheric loss, radiation exposure, and thermal extremes would eliminate the possibility of sustained survival. From a cosmic perspective, the debris from the supernova would not simply vanish. It would mix with Earth's remains, scattering elements across space. Heavy elements forged in the star's core, iron, gold, uranium, would mingle with the remnants of our planet. In a distant future, those materials might become part of new stars, planets, or even life forms elsewhere. The destruction of Earth in such an event would also contribute to the ongoing cycle